Welcome viewers, in this video we will see the design of 16:1 multiplexer using 8:1 multiplexer. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We need to design the 16:1 multiplexer using 8:1 multiplexer. So the multiplexer is nothing but having 2 to the power n input and 1 output with n selection lines. So this is the description of the multiplexer, having 2 to the power n input, only one output and n selection line. So multiplexer is nothing but many input to only one output, right? So based on this 16:1 means it is 2 to the power 4, 2 to the power 4 inputs and only one output, right? Having 4 selection lines. The 2 to the power 4, so that 4 selection lines. 8:1 mean it is 2 to the power 3:1 multiplexer, so 3 selection lines. There are 3 selection lines are available, right? So we need to design the 16:1 multiplexer, that is 2 to the power 4:1 having 4 selection line using the 8:1 multiplexer, that is 2 to the power 1 having 3 selection lines. Now we will see how to map these 4 selection lines in the 16:1 multiplexer and 3 selection line in the 8:1 multiplexer. So here 4 selection lines are available, but here only 3 selection lines are available. We will see how to connect this. So the step 1 is connect the selection line S2, S1 and S0 of the 2 multiplexer in parallel. So out of 4 selection lines, the 3 selection line, that is starting from LSB, is connected to 8:1 multiplexer. That is S3, S2, S1, S0 is the S3, S2, S1, S0 is the 4 selection line. Out of this starting from MSB, 3 lines are connected in parallel with two the multiplexer, 2 of the multiplexer, S0, S1 and S2, right? What about that another third selection line? The connect the most significant selection line. This is S3 is the most significant selection line S3, such that when S3 equal to 0, max 1 is enabled. When S3 equal to 1, max 2 is enabled, right? So the fourth selection line S3, that is MSB selection line, is used to enable the max 1 and max 2. S3 equal to 0 mean max 1 will be enabled, S3 equal to 1 mean max 2 will be enabled, right? So first 3 selection lines are connected in parallel with the max of the both the multiplexer. The fourth one, MSB, the selection line MSB of the selection line is used to select the max 1 and max 2, right? The step 3 is nothing but logically OR the output of the 2 multiplexers to obtain the final output of Y. So one OR gate is used. In that OR gate, the output of max 1 and max 2 is connected in order to get the final output, right? Now we'll go to the block diagram. Now we'll go to the logic diagram. So this is the first multiplexer, 8:1, the max 2, second multiplexer, 8:1, that is the MSB of the data are available from D8 to D15, D8, D9, D10, 11, 12, 13, 14, 15, right? So we have 16 inputs available. Out of 8 inputs are connected to the max 2 MSB line, starting from MSB, right? So this is the enable line. This is the selection line S3, S1 and S0. We already discussed out of 4, 3 selection lines are connected here, 1 selection line is connected to enable, right, as connected as enable. So this is the second output Y2, output of the second max Y2, right? So this is the 8:1 second max having LSB, having the data from LSB to 8 data are available with 1 enable and 3 selection lines. Now we'll go to the max 1, first max, MX 8:1 max 1. So here also having another 8 data starting from LSB, D0, D1, D2, D3, D4, D5, D6 and D7. That output is Y1. The enable is also available. then S2, S1, S0. So this is connected parallelly. S2, S1, S0 is connected parallelly. Both the mux S1, S1, S0 is connected parallelly, right. So this output Y is connected to one OR gate. This is Y1, this is Y2. Both are connected. So OR gate is the nature of adding the output. So these two inputs will be added and it will give the final output, right. So we have mux 1 and mux 2. The mux 1, there are 8 data available starting from LSB. In mux 2, 8 data are available starting from MSB. So totally 8 plus 8, 16 data, right. Now we are designed with the 16:1 multiplexer. So that 16 data are available with only one output. The selection lines are 4 selection lines. In case of 16:1 multiplexer, we have 4 selection lines. Out of 4, 3 is connected to the parallel to the 8:1 multiplexer. 8 S0, S1, S2, right. These 3 are connected in parallel with the 8:1 multiplexer, right. So this is the selection line of 16:1 multiplexer, out of which 3 are connected to the 8:1 multiplexer, right. Now we'll see what about the fourth one, MSB, the selection line MSB of the selection line S3. So we already discussed this this S3 is used to select the mux 1 and mux 2, right. It is used to select the mux 1 and mux 2, right. So this S3 is connected directly to the enable for the second mux, and it is connected through one OR gate to the enable of the first mux, right. So the S3 is used to select mux 1 and mux 2. S3 is directly connected to the enable of second mux, connected through the using one OR gate, connected through OR gate to the enable of the first mux, right. Suppose if S3 is 0, what will happen? If S3 is 0 means the 0 is connected to the second mux. So the second mux will not be enabled. The same 0 is applied here, but here one or NOT gate is available. So 0 become 1. So due to the 1, this is enabled. So the first mux will be enabled, right. So it will transfer the data. This first mux will be enabled. Out of the 8 data starting from LSP, any one data is available at the Y1, that is given to the OR gate, so that it will produce the final output, right. When S3 is 0, mux 2 is disabled, mux 1 is enabled, the data available in the first mux is transferred to the final output. Any one of the data starting from D0 to D7, any one of the data will be available. That is depends upon S0, S1, S2. Suppose 0, 0, 0, S0 is 0, S1 0 means D1 will be transferred. 0, 0, 1 means S0, 0 means D0 will be transferred. 0, 0, 1 means D1 will be transferred according to the binary number. That is three selection lines are available, so that 8 combinations will be there. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, like that. So accordingly, out of 8 inputs available, that will be transferred. For example, 0, 0, 0 means the first data, D0 will be transferred. Like that, it will transfer the other data. Finally, what we have 1, 1, 1. At the time, D7 will be transferred, right. So S3 is 0 means first mux is enabled based on the value of the selection line S0, S1, S2. There are 8 combinations are available. So for the 8 combination, out of 8 data, any one data is transferred. For example, the first combination is 0, 0, 0 means D0 will be transferred. Next one 0, 0, 1 means D1 will be transferred. Like that, it will go up to D7, that is 1, 1, 1, 1. So all the inputs are, all the selection lines are 1, 1 mean it will transfer the D7, right. Now we'll go to the second one. If the selection line is 1, what will happen? This 1 is applied to the enable. So the second mux is enabled, right. The same 1 is applied here, that becomes 0. After the NOT gate, the 1 is become 0. So that the first mux is disabled, right. When the selection line S3 is 1, now second mux is enabled, right. So 0 means first mux is enabled, 1 means second mux will be enabled, right. But now based on this data, based on the selection line, the input will be transferred. Any one of the input will be transfer to the output, right? So again here also same thing, 0 0 0 means the D8, the data D8 will be transferred. 0 0 1, so because of 3 bit there are 8 combinations available. 0 0 1 means the second one, D9 will be transferred, that is available in the Y, that is given to the OR gate, it is available as a final output. Similarly it will goes up to 1 1 1 1, 1 1 means the final, the MSB data, D15 will be transferred, right? So starting from 0 0 means first data D8, 0 0 1 means second data D9, like that it will go up to 8 combination. The final combination is 1 1 means D15 data will be transferred, right? So in this video we discuss how to design the 16:1 multiplexer using the two 8:1 multiplexer, right? Here we are having the two 8:1 multiplexer, 16:1 multiplexer having 4 selection line, 8:1 multiplexer having 3 selection line. So out of 4 selection line, 3 selection lines are connected parallelly. One more selection line is used to enable the mux, right? If the selection line, the MSB 0 means mux 1 is enabled, 1 means mux 2 will be enabled. When the mux 1 is enabled, the data D0 to D7 is, any one of the data D0 to D7 is transferred to the final output. Similarly, if the mux 2 is enabled, D8 to D15, any one of the data is transferred to the final output based on the value, 3 combinations 0 0 to 1 1 1. So subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. In this video we will see the design of 16:1 multiplexer using the 4:1 multiplexers. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We need to design the 16:1 multiplexer using the 4:1 multiplexer. So the multiplexer is nothing but having the 2 to the power n input and having only one output with n number of selection lines. So this is the description of the multiplexer. 2 to the power n input, one output and having n number of selection line. This selection line will decide out of n inputs which one will be available at the output will decided by the selection line. So 16:1 multiplexer means it is 2 to the power 4:1 multiplexer, 2 to the power 4, right? So n equal to here 4, so that we need 4 selection lines, right? So 2 to the power 4 inputs, 1 output and 4 selection line, that is 16 inputs, 1 output and 4 selection line. The 4:1 mean it is 2 to the power 2, 2 to the power 2:1, that is 4 input and 1 output. 2 to the power 2 mean 2 selection lines, 2 selection lines are available, right? So here 16 input, 1 output, 4 selection line. Here we have 4 inputs and 1 output with the 2 selection lines. Now we will see how to connect this 4 selection line with this 2 selection line. Here we need only 2 selection line, but here 4 selection lines are available, and also here 4 inputs, but we have 16 inputs are available. We need to connect 16 inputs, but 4:1 multiplexer having only 4 inputs. So in order to connect 16 input, what we have, 4 into 4, there are 4 multiplexers are needed, 4:1 multiplexers needed, so that 4 into 4 we can connect 16 inputs, right? 4 into 1 multiplexer able to connect only 4 inputs, but we need to connect 16 inputs. So 4 into 4, what we need, 4 multiplexers are needed, 4:1 multiplexers are needed, right? So that is given here. Since there are 16 inputs for the multiplexer, we require 4:1 multiplexer to satisfy the input needs. The 4 outputs of 4:1 multiplexer are again multiplexed by one more 4:1 multiplexer to generate the final output, right? So we are using 4 multiplexers to connect these 16 inputs, so that we got the 4 output from 4 multiplexer. 4 output will be available, but we need only 1 output, so that again this 4 multiplexer, the output of this 4 multiplexer are connected by another multiplexer, so that we'll get only final output, right? So we have totally 5 multiplexers are needed. 4 multiplexers are used to connect these 16 inputs, so that we got 4 outputs from the 4 multiplexer. In order to multiplex these 4 outputs, again one more multiplexer is connected, so that we'll get only one output, right? Now we'll see how to connect this 5 multiplexers. So totally now we have 5 multiplexers are available. So connect the selection line S1 and S0 of the 4 multiplexer in parallel. So we have 4 selection lines, out of which the LSB S0 and S1 is connected to first 4 multiplexers in parallel. All the 4 multiplexers are connected with S0 and S1 in parallel, right? So we have one more multiplexer is available. So the MSB S3 and S2 is connected to multiplexer fifth multiplexer, right? First 4 multiplexer connected with S0 and S1. The fifth one is connected with S3 and S2, right? So connect the output of Y0, Y1, Y2 and Y3 of the 4 multiplexer as a data input for multiplexer 5, right? So the first 4 multiplexer, we have 4 outputs are available. That is nothing but input to the fifth multiplexer, so that this fifth multiplexer will produce only one output, right? So we have 5 multiplexers are available. In that, the LSB of the selection line is connected to the first 4 multiplexers, right? Then MSB of the selection line S3 is S2 is connected to fifth multiplexer. The output from the 4 multiplexer is connected to the input of the fifth multiplexer, so that fifth multiplexer will produce only one output. Now we'll see the logic diagram. So this is the 4 multiplexers. Multiplexer 1, 2, 3, 4. 4 is to 1 multiplexer, 4 multiplexers are available, right? So the multiplexer 4 having the data D0, D1, D2, D3. 4 data are available. So totally 16 data is available, starting from D0 to D15, out of which 4 data are connected to each multiplexer. So the multiplexer 4 having D0, D1, D2 and D3. Multiplexer 3 having D4, D5, D6 and D7, 4 data. Multiplexer 2 having D8, D9, D10, D11, 4 data. Multiplexer 1 having D12, D13, D14 and D15, right? So out of 16 data, 4 data are connected to the 4 multiplexer. D0 to D3 connected to 4th multiplexer, D4 to D7 connected to 3rd multiplexer, D8 to D11 connected to 2nd multiplexer, D12 to D15 connected to 1st multiplexer. So there are 16 data. So S1 and S0 is connected to selection line of all 4 multiplexers. S1 and S0 having 2 variable, 4 combinations are available. So if it is 0, 0, 0, 0 means the first data, LSB data from in each multiplexer will be enabled. For example, here D0 will be available as the output. Similarly, here D4 is available at the output. Similarly, here D8 is available at the output. Similarly, here D12 will be available at the output. For the selection line 0, 0 means the LSB data. D0, D4, D8 and D12 will be available. The second combination 0, 1. 0, 1 means next data. D0 means D1. D4 means D5 will be available. D8 means D9. D12 means D13 will be available at the output, right? The next data. Similarly, the next combination 1, 0. 1, 0 means D0, D1, then D2 will be available at the output. Here D6 will be available. Here D10 will be available. Here D14 will be available at the output. The last combination 1, 1. 1, 1 means this final data. D3 will be available at the output. Here D7 is available at the output. Here D11. Here D15. Right. So S1 and S0 is connected parallelly. For 4 combination, the corresponding data will be available. For example, 0, 0 means LSB data available. 0, 1 means next data. 1, 3 means third data. 1, 1 means the MSB data. So that every output Y0, Y1, Y2 will be produced the out of 4 any one will be available. Out of D0 to D3 any one will be available. Now these 4 outputs are connected to one more multiplexer, right? So that we will get only what we need is only one output, right? So now that is connected with the another two selection line S2 and S3. So it is connected with I0, I1, I2, I3. So I0 may be this output either D0, D1, D2 or D3. I1 is nothing but either any one of this output D4, D5 or D6 or D7. I2 is nothing but any one of this output D8 or D9 or D10 or D11. Similarly, I3 is nothing but any one of this output either D12, D13, D14 or D15, right? These 4 outputs, out of 4 output, any one will be available here based on the selection line, right? Again, how to segregate this output? By using this S3 and S0 is connected, right? So S3 is 0, 0. S3 is 0, 0 mean what will happen? The output I0 will be available. I0 will be available at the output, right? This is the LSB data. So that I0. What is I0 value? I0 may be D0 or D1 or D2 or D3. That is depends upon the selection line of this mux, right? So next combination 0, 1. 0, 1 means second data. I1 will be available at the output. The I1 may be D4 or D5 or D6 or D7, right? The third combination 1, 0. 1, 0 mean I2 will be available at the output. I2 is nothing but either D8 or D9, D10 or D11. The last combination 1, 1. 1, 1 mean I3 will be available at the output. I3 is nothing but either D12, D13 or D14 or D15. So finally we got only one output. Starting from D0 to D15, any one output will be available as a multiplexer output of only one output, right? So these are all decided by the selection line. First selection line S0 and S1, that will decide this data. Then S3 and S3 will decide this output. So finally we got only a one output. So in this video we discussed how to design 16:1 multiplexer using 4:1 multiplexers. We discussed the how to connect the selection lines. How many multiplexers are needed? There is 4 multiplexers needed to connect 16 data. In order to streamline this 4 multiplexer, we need one more multiplexer. So 5th multiplexer. That multiplexer is finally produce single output, right? The 2 selection lines are connected parallelly to the all 4 multiplexers. Another 2 selection lines connected to the 5th multiplexer, so that we got single output. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.